All right, welcome. So in the world of software quality, there are these three words that get thrown around constantly: error, fault, and failure. Now they sound pretty similar, right? But, and this is a big but, understanding the difference between them is absolutely crucial if you want to build better software. Yeah, exactly. In just regular conversation, we kinda use them all to mean the same thing. Your app crashes and you might say, oh, there's a bug, or it's an error, or we've got a failure. But when we're talking about software testing, these words have super specific, connected meanings. So, are they the same? Well, the short answer is not even close. Okay, so today we're going to untangle this whole thing once and for all. We'll kick things off with a common confusion, then walk through how an error leads to a fault and how that fault causes a failure. We'll connect all the dots, and then, most importantly, talk about why this distinction actually matters. All right, let's jump right in. The very first thing you need to get is that this whole chain of events, it always starts with a person. It kicks off with a human action. And that's what we call an error. Plain and simple, an error is a mistake made by a person. Think about a developer who just misreads a requirement, or maybe a business analyst doesn't quite get what a customer needs. Heck, it could even be a simple typo in the code. It's that initial human action that kicks this whole thing off. Right, and this is a really key point. The book, Software Testing Foundations, puts it perfectly, saying, a fault is always the result of an error or a mistake made by a person. Think about that. The computer doesn't just wake up one day and decide to create a problem. Nope, the problem gets put into the system because of a person's mistake. Okay, so we've established that a person makes an error. So what's next? Well, that mistake doesn't just disappear. It actually gets built into the software. And that brings us to the next piece of the puzzle. This is what we call a fault. A fault is what you probably call a defect or, a bug. It's the direct result of that human error we just talked about. It's the actual physical, incorrect line of code. It's that flawed piece of logic that is now sitting, just living, right there inside the system. And here's the crazy part. A fault can just sit there. It's static. It can lie dormant in the code, completely unnoticed for weeks, months, sometimes even years. The system isn't actively breaking, not yet anyway, but you've basically got this little ticking time bomb hidden deep inside the code. So, to put it simply, the error is the action. It's the developer misinterpreting a business rule. The fault, on the other hand, is the result. It's the incorrect if statement that got written into the program because of that misunderstanding. Action, then result. Simple as that. All right, so just to recap, we've got this quiet, dormant fault just sitting in our code. So far, so good. Nothing has actually gone wrong. But that brings us to the final piece of this puzzle. What happens when the system finally runs that specific piece of faulty code? And that is the failure. A failure is the moment everything goes sideways from the user's point of view. It's the app crashing. It's the wrong number showing up on the screen. It's the button you click that does absolutely nothing. A failure is the external, observable thing that tells you something is wrong. It's the visible symptom of that hidden fault we talked about. And the timing here is everything. The source material says it best. Failures only become apparent when the system is actually running. The fault has to be triggered. That faulty code has to be executed for the problem to actually show itself. Until that exact moment, it's just a fault, waiting in the wings. Let's make this super clear with an example. The fault is the internal problem, right? It's the incorrect formula for calculating a discount that's buried somewhere in the code. The failure? That's the external behavior. That's the customer at checkout getting charged the wrong amount. The fault is the cause. The failure is the effect you actually see. Okay, so let's connect all the dots now. We're going to put all three of these pieces together into one single logical chain. This is where it should all really click. Here's the whole sequence. Step by step, first a human makes an error. That error then creates a fault, the bug in the code. Then way down the line, when that specific code gets run, the fault leads to a failure. So error creates a fault and an executed fault causes a failure. It's a chain reaction. And it's worth noting, not every fault will cause a failure, but every single failure is caused by a fault. This table really lays it all out nicely. Look at the error. It's a human mistake, and it happens during development. That error immediately creates a fault, a defect in the software. But the failure, that's the incorrect behavior, and it only pops up much later, at runtime, when someone, a user, a tester, actually triggers that fault. Okay,
So at this point, you might be thinking, why does this matter so much? Does it really make a difference if I call it a bug or a failure? And the answer is, oh yeah, it absolutely does. Being this precise with your language has some seriously powerful benefits.
For sure. I mean, think about it. When your team can talk about these things clearly, you solve problems way faster. If you report a failure, the thing the user saw, the developer's job is to go hunt down the fault that caused it. And then, for the really good teams, they do a root cause analysis to trace that fault all the way back to the original human error. And that's the magic right there. Because now you can not only fix the bug, you can change your process to make sure that kind of error doesn't happen again. It's about fixing today's problem and preventing tomorrow's.
So we'll leave you with this question to think about. The next time you see a problem in your system, try not to just fix the symptom. Instead, ask your team, how can we trace this failure back to its underlying fault, and then all the way back to the root error? Because that is how you start building truly exceptional software.